Here is something your doctor may not have told you at your last checkup. Right now, as you are watching this, your body is quietly losing muscle. Not because you are lazy, not because you are sick, but because after the age of 60, your biology has changed in ways that work directly against your muscle tissue every single day. The good news? 3 of the most affordable, accessible foods on the planet have been shown in clinical research to fight back against this muscle loss. They are not exotic supplements, expensive powders, or specialty items available only in health food stores. You can find all 3 of them in almost any grocery store in the world, and together they cost less per day than a cup of coffee. But before we get to those 3 foods, you need to understand what is actually happening inside your body and why it matters so much. The medical term for age-related muscle loss is sarcopenia, from the Greek words meaning poverty of flesh. It was formally recognized as a disease in 2016 and given the International Classification of Disease Code M6284. According to research published in leading nutrition journals, adults typically begin losing between 0.5% and 1% of their whole body skeletal muscle mass per year, starting around age 50, and this rate accelerates after age 60. In terms of strength, the decline can be even steeper, between 1.5% and 5% per year in leg muscle strength. Over a decade, this adds up to a 10% to 50% reduction in the very tissue that keeps you upright, mobile, and independent. Currently, sarcopenia affects between 10% and 16% of adults aged 60 and older worldwide. By age 70, that number climbs to approximately 20%. By age 80, some estimates suggest more than 50% of older adults are affected to a clinically significant degree. Research consistently links sarcopenia to increased risk of falls and fractures, reduced ability to perform daily activities, higher rates of hospitalization, insulin resistance, diabetes, cardiovascular disease, depression, and increased mortality. Studies have shown that loss of muscle strength is directly associated with elevated risk of death, particularly in men over 60, where the rate of strength loss is among the strongest predictors of mortality. This is why sarcopenia is not just about looking strong. It is about staying alive, staying independent, and maintaining the quality of life you deserve. The root cause of sarcopenia is a progressive imbalance between muscle protein synthesis, the process of building new muscle tissue, and muscle protein breakdown. In young, healthy adults, these 2 processes are roughly balanced. As we age, several biological changes tip the scales toward breakdown. One of the most important of these changes is called anabolic resistance. Research published in peer-reviewed journals has shown that older adults require significantly more dietary protein per meal to trigger the same muscle-building response that a much smaller amount would produce in a younger person. One study found that older individuals with a mean age of around 71 may require almost twice as much protein per meal to stimulate muscle protein synthesis compared to their younger counterparts. The mechanism behind this involves the mTOR, mechanistic target of rapamycin, signaling pathway which acts as the cellular on-switch for muscle protein synthesis. In aging muscle, this pathway becomes less sensitive. The amino acid leucine, found in high concentrations in certain foods, is one of the most potent natural activators of this pathway, and research suggests that older adults need substantially more leucine at each meal to generate the same anabolic response as younger people. Additionally, aging brings with it a decline in anabolic hormones, reduced physical activity, changes in gut microbiome composition that affect amino acid absorption, and increased levels of chronic low-grade inflammation, sometimes called inflammaging, which directly accelerates muscle protein breakdown. The combination of these factors creates a biochemical environment that is, in the absence of dietary and lifestyle intervention, persistently hostile to muscle maintenance. There is also a dietary dimension. Research has found that older adults with sarcopenia consistently show lower intake of protein-rich foods, including meat, eggs, fish, and dairy, compared to non-sarcopenic older adults. Lower intake of leucine, valine, and tryptophan, amino acids found abundantly in animal-sourced foods, is specifically associated with elevated sarcopenia risk. The good news, supported by decades of human clinical research, is that these biological changes are not destiny. Nutritional intervention, specifically the right foods, consumed in the right amounts, at the right times, can meaningfully slow, stop, and in some cases partially reverse sarcopenia. And the three foods we are about to discuss are among the most evidence-backed options science has identified. Superfood. 1. Eggs. Eggs are one of the most studied foods in the context of muscle protein synthesis, and the science behind them is striking. A single large egg contains approximately 6 grams of high-quality complete protein, meaning it provides all 9 essential amino acids your body cannot make on its own. But what sets eggs apart is not just how much protein they contain. It is the quality and bioavailability of that protein. Protein quality is typically measured using a scoring system called the Digestible Indispensable Amino Acid Score, DIAAS, which replaced the older PDCAS method. By this measure, eggs score among the highest of any whole food. Their amino acid profile closely matches what human skeletal muscle requires. Critically, eggs are one of the richest food sources of leucine, the branched-chain amino acid that scientists have identified as the primary trigger for mTOR activation and muscle protein synthesis. Research supports what has been called the leucine trigger hypothesis, the idea that the magnitude of the blood leucine rise after eating a protein-containing meal determines how strongly muscle protein synthesis is stimulated. In older adults specifically, 16 of 29 eligible studies in a systematic review published in Frontiers in Nutrition confirmed that the leucine content of a food is a key determinant of its muscle-building response. Beyond leucine content, researchers have found something particularly compelling about whole eggs versus egg whites. A study cited in leading nutrition literature found that consuming whole eggs promotes a significantly greater stimulation of post-exercise muscle protein synthesis than consuming an equivalent amount of protein from egg whites alone, even when leucine concentrations in the blood are similar between the two groups. This suggests that other components of the egg yolk, including lipids, vitamins, and bioactive compounds, play a modulatory role in how efficiently the body uses the protein. The food matrix matters. Whole eggs, eaten whole, appear to be more anabolically potent than their protein content alone would predict. For older adults navigating anabolic resistance, this finding is particularly relevant. The research suggests that ingestion of approximately 25 to 30 grams of high-quality protein per meal maximally stimulates muscle protein synthesis in older individuals. That is approximately 4 to 5 whole eggs, or eggs combined with other high-quality protein sources. Research also emphasizes that distributing protein intake evenly across meals, rather than consuming most protein at dinner, is important for maximizing daily muscle protein synthesis. A review published in a peer-reviewed nutrition journal specifically noted that because eggs provide high-quality protein which stimulates muscle protein synthesis, their consumption can help reduce the risk of functional decline in older adults. Animal-sourced proteins, including eggs, were found in a landmark 9-year longitudinal study to be associated with greater lean mass and lower risk of sarcopenia-related functional decline compared to plant proteins, particularly in adults who do not exercise regularly. Eggs also supply vitamin D, which deserves its own discussion. A lack of vitamin D is now recognized as a major contributing cause of sarcopenia, according to research published in PMC journals. Vitamin D receptors are found in skeletal muscle cells, and deficiency impairs muscle function at the cellular level. While the egg yolk is not the richest source of vitamin D available, it contributes meaningfully to daily intake, particularly important for older adults who may have limited sun exposure. Finally, eggs are rich in choline, a nutrient that supports neuromuscular function. The nerve-muscle connection, the neuromuscular junction, deteriorates with age, contributing to both muscle loss and loss of strength. Choline plays a structural role in maintaining these connections. Practical guidance. Aim for 2 to 4 whole eggs per sitting as part of a protein-containing meal. Choose whole eggs over egg whites to capture the full nutritional matrix. If there are cardiovascular concerns, consult your physician, But note that current scientific consensus has significantly evolved regarding dietary cholesterol and heart disease risk, with major dietary guidelines no longer recommending strict cholesterol limits for healthy individuals. Superfood number 2, canned sardines. Canned sardines may be one of the most underappreciated nutritional powerhouses on the market. They are inexpensive, shelf-stable, require no preparation, and pack an extraordinary density of nutrients specifically relevant to sarcopenia prevention and reversal. Let us start with protein. A 92-gram can of sardines provides approximately 22 to 25 grams of complete high-quality protein, nearly as much as a comparable serving of lean chicken or beef. That is a meaningful dose, approaching the 25 to 30 grams per meal, that research identifies as optimal for maximally stimulating muscle protein synthesis in older adults. And sardine protein, like egg protein, has an excellent essential amino acid profile, including meaningful amounts of leucine, which is critical for activating the mTOR pathway. But sardines' most distinctive contribution to muscle health comes from their omega-3 fatty acids, specifically EPA, eicosapentaenoic acid, and DHA, docosahexaenoic acid. A single 92-gram can of sardines contains approximately 1.48 grams of omega-3s, including over 900 milligrams of combined EPA and DHA. To put this in perspective, according to NHANES data, the average American consumes only about 35 milliliters of EPA and 76 milliliters of DHA per day. A single can of sardines provides roughly 8 times that amount. Why does this matter for muscle? The evidence is increasingly compelling. Research published in PMC, specifically a review focused on dietary omega-3s and muscle composition in older adults, found that omega-3 fatty acid supplementation is associated with hypertrophic responses in older adults, including improvements in the rate of muscle protein synthesis and mTOR signaling during amino acid availability, as well as increases in muscle volume following prolonged supplementation of 8 to 24 weeks. The mechanism involves omega-3 fatty acids' ability to help overcome anabolic resistance in aging muscle. EPA and DHA appear to sensitize aging muscle cells to the muscle-building effects of amino acids, essentially lowering the threshold at which protein can trigger muscle protein synthesis. One review published in PMC on the effect of omega-3 fatty acids on sarcopenia noted this as a key mechanism of action. Additionally, omega-3s reduce chronic inflammation, the persistent low-grade inflammatory state that directly accelerates muscle protein breakdown in older adults. By lowering pro-inflammatory cytokines and prostaglandins, EPA and DHA help shift the biochemical balance back toward muscle preservation. A 2023 PMC review specifically examining sardines and their nutrient matrix noted that sardines offer a remarkable combination of nutrients beyond just omega-3s. They contain high-quality protein, vitamin D, calcium, selenium, vitamin B12, and taurine, creating a multi-nutrient package that is difficult to match with any supplement combination. Sardines cooked with their bones, as canned sardines are, provide approximately 351 milliliters of calcium per can, which is about one-third of the daily requirement for most adults. This matters for muscle, because calcium is not just a bone mineral. It plays a critical role in muscle contraction. Every time a muscle fiber contracts, calcium is released inside the cell to trigger the contraction mechanism. Adequate calcium intake supports the neuromuscular function that is already being compromised by aging. Sardines are also a source of vitamin D, one of the few food sources that provides meaningful amounts. As discussed, vitamin D deficiency is a recognized major cause of sarcopenia. A single serving of sardines can provide 10% to 12% of the daily recommended amount, contributing to the overall daily total that older adults need. The vitamin B12 content of sardines is exceptional. A 92-gram can provide approximately 343% of the daily value. B12 is critical for neuromuscular function, energy metabolism in muscle cells, and the maintenance of nerve pathways connecting the brain to skeletal muscle. Deficiency in B12, which becomes more common with age due to reduced intrinsic factor production, is associated with muscle weakness and impaired physical performance. Selenium, present at 88% of the daily value per can, is an antioxidant that protects muscle fibers from oxidative damage. Chronic oxidative stress, the accumulation of reactive oxygen species in tissue, is one of the proposed mechanisms accelerating sarcopenia. Selenium-containing enzymes are part of the body's primary defense against this oxidative damage. One more advantage of sardines worth noting: they are one of the lowest mercury seafood options available, confirmed by joint FDA and EPA advisories. Because sardines are small, short-lived, and low on the food chain, they do not bioaccumulate mercury the way larger predatory fish do. This makes them one of the safest fish for regular consumption by older adults. A 2023 peer-reviewed review published in a PMC journal explicitly compared sardine consumption to fish oil supplementation and concluded that sardines offer a clinically relevant matrix of nutrients that provides cardiovascular and metabolic benefits beyond what omega-3 supplements alone can deliver, at a fraction of the cost. Practical guidance: aim for 2 to 3 cans of sardines per week, at minimum. Choose sardines packed in water or olive oil, with bones included, for maximum calcium content. Canned sardines can be eaten directly from the can, mixed into salads, spread on whole grain crackers, or incorporated into pasta dishes. If the strong flavor is a barrier initially, start with sardines packed in tomato sauce or mustard, which helps moderate the taste. Superfood 3. Plain Greek yogurt. Greek yogurt has emerged as one of the most research-supported whole food protein sources for older adults seeking to maintain or rebuild muscle. Its advantages over regular yogurt, and over many other protein foods, come from a combination of protein concentration, amino acid quality, protein absorption kinetics, and the presence of beneficial bacterial cultures. The most important starting point is protein content. A 170 to 200 gram serving of plain, unsweetened Greek yogurt contains approximately 15 to 20 grams of complete protein, depending on the brand. This is the result of the straining process used to make Greek yogurt, which removes much of the liquid whey and concentrates the protein, primarily casein, to a significantly higher level than found in regular yogurt. The casein-to-whey ratio of Greek yogurt's protein has important implications for older adults. Casein is a slower digesting protein that results in a more sustained elevation of blood amino acid concentrations over several hours compared to the rapid spike and fall produced by whey protein isolates. Research has shown that older adults, due to anabolic resistance, benefit particularly from prolonged amino acid availability, as it gives aging muscle a longer window to respond to the anabolic stimulus. The combination of whey, faster, and casein, slower, that naturally exists in dairy proteins, including Greek yogurt, may provide an optimal kinetic profile for muscle protein synthesis in older individuals. A key study published in the American Journal of Clinical Nutrition in 2018, a randomized controlled trial involving healthy older women aged 65 to 75, found that protein leucine content was a significant determinant of muscle protein synthetic responses in this age group. Dairy protein, which includes Greek yogurt, was shown to stimulate muscle protein synthesis significantly better than equal amounts of protein from lower leucine sources. Greek yogurt, with leucine representing approximately 10% of its total protein, provides a leucine dose per serving that approaches the threshold researchers have identified as necessary to meaningfully activate mTOR signaling in aging muscle. A randomized controlled trial published in Frontiers in Nutrition examined the effects of Greek yogurt consumption combined with 12 weeks of resistance training in young adults. The Greek yogurt group gained significantly more total strength, greater biceps muscle thickness, more fat-free mass, and experienced greater reduction in body fat percentage compared to a carbohydrate-matched control group. While this study was conducted in younger adults, the mechanistic basis, leucine-driven mTOR activation, sustained casein digestion, complete essential amino acid delivery, applies equally and is, if anything, more important in older adults who face greater anabolic resistance. In 2025, an 8-week randomized pilot intervention trial published in PMC examined the effects of Greek yogurt specifically in older adult exercisers aged 55 and older. Participants consumed 2 daily servings of 175 grams of Greek yogurt, providing 17 grams of protein and 225 milligrams of calcium per serving. The study examined markers of bone turnover and inflammation, providing additional insight into how whole food dairy protein behaves in older populations. The authors noted the need for longer intervention studies to determine the full extent of benefits, while highlighting Greek yogurt's potential to support skeletal and immune health in older exercisers. Beyond protein and leucine, Greek yogurt provides significant calcium, approximately 200 to 250 milligrams per serving depending on the brand. As discussed with sardines, calcium is essential not just for bone health, but for the muscle contraction mechanism itself. Greek yogurt's calcium comes packaged with other dairy components that enhance its absorption, including vitamin D in fortified varieties, and the naturally acidic pH created by fermentation. Greek yogurt also contains live and active bacterial cultures, beneficial probiotic bacteria including Lactobacillus acidophilus and Bifidobacterium lactis. This may have direct relevance to sarcopenia through an often overlooked pathway, gut health, and amino acid bioavailability. Research has found that the gut microbiome plays a role in amino acid synthesis and absorption. Some species, including Prevotella, are involved in the synthesis of lysine and contribute to leucine availability. Aging is associated with dysbiosis, changes in gut microbiome composition that can impair protein digestion and amino acid absorption. Probiotic bacteria in fermented foods like Greek yogurt may help support a healthier gut environment, improving the efficiency with which dietary protein is converted into usable amino acids. There is also evidence that regular consumption of fermented dairy products may help attenuate chronic low-grade inflammation, a key driver of sarcopenia. A 2024 randomized crossover trial in adults and older adults comparing fermented dairy products, including yogurt, to non-fermented dairy found that fermented products positively affected metabolic risk markers including blood pressure, fasting insulin, C-peptide, HOMA-IR, and blood lipids. While direct anti-sarcopenic effects still require further investigation in longer-term trials, the metabolic improvements associated with fermented dairy support the systemic conditions that favor muscle maintenance. Research also strongly supports the timing and frequency of protein consumption from sources like Greek yogurt. Studies recommend that older adults aim for 25 to 30 grams of high-quality protein at each of 3 main meals per day, rather than consuming most protein in one sitting. Greek yogurt fits naturally as a high-quality protein source at breakfast or as a mid-morning or afternoon snack, meals where many older adults tend to underconsume protein. Practical guidance. Choose plain, unsweetened Greek yogurt. Flavored varieties frequently contain added sugars that do not contribute to muscle health and may blunt some of the beneficial metabolic effects. Aim for at least 2 servings daily. Consume it as a standalone snack. Mix it with berries, which provide antioxidants relevant to reducing exercise-induced inflammation. Use it as a base for dips and dressings, or blend it into smoothies. Look for varieties that specify live and active cultures on the label to ensure probiotic benefit. How to use these 3 foods together. Each of these foods is powerful on its own. Together, they form a complementary nutritional foundation that addresses the multiple biological mechanisms driving sarcopenia in older adults. Eggs provide an immediate, highly bioavailable protein with an unmatched anabolic amino acid profile and the full nutritional matrix of the yolk. Sardines deliver omega-3 fatty acids that sensitize aging muscle to protein, combat the inflammation that drives muscle breakdown, and supply vitamin D, B12, calcium, and selenium, a multi-nutrient package that no single supplement replicates. Greek yogurt contributes slow-releasing casein protein with an ideal leucine concentration, beneficial probiotic bacteria to support gut absorption, and calcium, timed perfectly for meals when eggs and sardines may not be consumed. Sample daily structure supported by research. Breakfast, 3 to 4 whole eggs, scrambled, boiled, or poached, alongside a 170-gram serving of plain Greek yogurt. This provides approximately 35 to 40 grams of high-quality protein with excellent leucine density, approaching the upper range of what research suggests maximizes muscle protein synthesis per meal in older adults. Lunch or dinner, 2 to 3 times per week. 1 can of sardines alongside other foods. Combined with additional protein sources, cottage cheese, lean meat, legumes, this meal builds toward the 25 to 30 gram per meal protein threshold while delivering omega-3s, vitamin D, and calcium. Afternoon snack. An additional 170-gram serving of Greek yogurt, optionally paired with a small amount of fruit or nuts. This structure helps distribute protein across the day, a strategy supported by research as more effective for muscle protein synthesis in older adults than front-loading protein consumption, while delivering the nutrients most critically implicated in sarcopenia prevention. No discussion of sarcopenia would be complete without acknowledging the role of exercise. The research is unequivocal. Resistance training is the first-line, gold standard treatment for sarcopenia, recognized unanimously across international research bodies. Nutrition and exercise are synergistic, each makes the other more effective. Resistance training, including bodyweight exercises, resistance bands, or light weights, sensitizes aging muscle to the anabolic effects of protein. Research has shown that even a modest bout of physical activity can restore the ability of aging muscle to respond to protein intake. The combination of adequate protein from high-quality sources and regular resistance exercise produces greater improvements in muscle mass and strength than either intervention alone. A few important clarifications grounded in science. Protein quantity matters. The current recommended dietary allowance (RDA) of 0.8 grams of protein per kilogram of body weight per day is widely considered insufficient for older adults. Research and clinical recommendations from organizations such as the European Society for Clinical Nutrition and Metabolism support a target of 1.0 to 1.2 grams of protein per kilogram of body weight per day for older adults in general, and potentially 1.2 to 1.5 grams for those with sarcopenia or who are physically active. Always consult your physician or registered dietitian to determine the appropriate target for your individual health circumstances, particularly if you have kidney disease, where protein intake may need to be managed differently. Vitamin D status should be checked. Given its recognized role as a major causal factor in sarcopenia, vitamin D deficiency should be tested and addressed. Food sources, including eggs and sardines, contribute, but many older adults require supplementation to reach optimal serum levels. Ask your doctor for a 25-hydroxyvitamin D blood test. These foods work best as part of an overall healthy diet. A 2023 research review on eating habits tied to sarcopenia cited evidence supporting combined elements of the Mediterranean and DASH dietary patterns as providing a nutrient-dense eating approach that can help improve muscle mass and function in older adults. The 3 superfoods described here align naturally with these evidence-based dietary patterns. Consistency is key. Research on nutritional interventions for sarcopenia consistently shows that sustained, regular dietary changes, not short-term experiments, produce meaningful gains in muscle mass, strength, and function. Most clinical trials showing significant results ran for 12 to 24 weeks or longer. Sarcopenia is real, it is measurable, it is consequential, and it is not inevitable. The science is clear that dietary intervention, particularly with high-quality protein sources rich in leucine and omega-3 fatty acids, combined with regular physical activity, can meaningfully slow, stop, and partially reverse the muscle loss that threatens independence and health after 60. Eggs, canned sardines, and plain Greek yogurt are not glamorous. They will not trend on social media or appear in luxury health food stores at $30 a jar, but the evidence supporting them, peer-reviewed, published in leading journals, replicated across multiple research groups, is as solid as nutrition science gets. 3 inexpensive foods, decades of research. One clear message: it is never too late to start feeding your muscles what they need to fight back.